Hello everyone. So this is our second tutorial on Python. And following what we did last time, we're going to do the experiment on roll a die. You probably already expected that. So here I'm going to show you, before that, I'm going to show you, right, if I already uploaded the Python notebook or Jupyter notebook online, but here's how to upload that. So what you can do is that click, enter whatever folder you have, click upload here, and then go to the tutorial or the code you want to upload. Basically, end as .ipynb. So I'm going to click here and upload, right? Select upload, and it's uploaded here. So I can open this, and you can see that whatever codes I created before, they're already here, right? They're already here. So I'm going to you can run this with no issue. I'm just run again to clean up all the codes we have before. So here, the first one we're going to do is that we do the experiment on roll a die, and find out if what is the probability to get a 5, right? We know already it should approach to about 1/6, right? But that's what we're going to prove here. So very similar to what we did before, right? We're going to create a list outcome of rows to this what I created here is a new variable, you can think it as, but it's basically a list, right? A list which I'm going to hold the outcomes of the result inside of this list. So what I can do is that, let's say I'm going to roll the die for, let's just say 10 times, start with 10 times, right? And x, still the result we had before, the variable we had before, is a random, it's from a random, it's a variable that basically is the outcome of random choose an integer from 1 to 6. This is basically what we did before, we already know that, right? Then the outcome will be added into the list here. So I'm going to append whatever the outcome of the random chosen integer from 1 to 6, put that into the die, right, x. So I can run it here to show you what the list looks like. It's basically like this, right? So this means for the first row, I got a 5, and I add a 5 to this list. So this is a list to hold all the outcome of rolling a die, right? This first time I got a 5. Second time we're lucky, we got a 6. Third time another 6. Fourth time 2. Fifth time 4, so on and so forth, right? This is what we get. And we run this 10 times, right? I'm going to remove this, but we can certainly run this 10,000 times or 100,000 times, doesn't matter, right? Now, basically, what we want to find out is that out of this 10 times, how many times we got 6, right? Or how many times we got 5? This is easy. We have 10, we run 10 times, we only get 1 5, so it's easy to count, right? But what if we actually did this for 100,000 times? What if we did this for 100,000 times? That's not easy to count anymore, right? So we want Python to help us to do the counting. So basically, that's why I import another package, which is called collection. Under collection, in the package of collection, there's a function that can help me to find out how many times are there if we throw a die for 10,000 times, 100,000 times, how many are 5? So what I'm going to do is that I use counter equals to collections dot counter list, list of the outcomes, right? See, I call it counter. You don't have to call it counter. You can just call it count phi, right? Or count results. Doesn't matter what you call it. It's something we determined, right? But here in enter the collections, we do have to use counter here, and you can see C is capital letter, meaning that in the package, we use this counter method, we try to find out what are the results here. And I'll show you what it gives us. So I'm going to print count result. So that's what it gives me. It gives me in the counter how many times we got 1, how many times we got 3, how many times we got 6, how many times we got 4, how many times we got 5, and then how many times we get 2, right? So you can see here that out of this 107 times, we got 16,611 fives. And you know, if you're curious about the probability here, this basically just equals to 16611 divided by 100,000 times, right? This guy give us 0.166, very close to 16. So you see that, again, we use Python to confirm that if we throw a die for 100,000 times or many, many times, the chance we got 5 is pretty similar to the chance we got 1 or 2 or 3 or 4 or 6, approaching about 0.167, right? Something like that. So I hope this makes sense. It's basically the entirely like what we did before with a coin, but here we use list to hold the result, and then we use count our counter here from the collections to find out the numbers of results, right? Related to this, I don't know if you still remember this, right? This question we did in the class. We said that you're going to roll a fair 6-sided die at most 3 times. You can stop whenever you want and receive as a reward the number of your last roll in cash, right? What should your strategy be in playing this game? We talk about this in class, right? If we throw 1 time, if I only allow you to throw 1 time, well, you're going to think the chance will be about 3.5, right? The average number you're going to get is 3.5, meaning that if you get a 3, you are not going to be satisfied. If you get a 4, you're thinking, okay, I'm good, right? I expect to get a 3.5, I got a 4, I'm happy. But if not 1 time, if I can actually allow you not 3 times as well, if I allow you to 3 many, many times, as many times as you want, you will not stop until you get a 6, right? Because once approach infinity, well, absolutely you're going to get a 6, right? But what happens if it's 3 times? At what point 3.5 will not satisfy you anymore, and you need a 4 or even a 5 or even a 6, right? So that's what we are trying to find out here. And basically use this to inform, well, if you can throw 3 times, are you still going to be satisfied if you get a 4? Or, you're actually going to, you get a 3, or you want something better, right? So that's what we're trying to do here. Again, I'm going to import random. What I'm doing is pretty similar, right? If I'm just throwing this die once, meaning that I'm doing the experiment once, but I throw this 3 times, throw the die 3 times, throw the die 3 times as one experiment, right? So what I'm going to do is that I say for I in range 3, I'm going to throw 3 times, right? And then the list. All right, so actually, let's hold it here. I'm going to still use a list of outcomes as row. I'm just going to copy paste here. This is, we're using the list, I'm going to hold the result, right? Then I'm going to throw x, I'm going to do a loop, and then for loop of 3, basically, I'm throw it 3 times. Each time, I'm going to do a random draw from 1 to 6 again, right? And then list of outcomes, I'm going to append x, right? I'm appending the x. Then what I want to find out is that the maximum value, right? Maximum, what you're going to do, what you're going to get. So I'm printing max list outcomes. Of course, this is not entirely correct because you need to stop at a certain time, right? But let's say, you can throw 3 times, just thinking about expectations, what you're going to get, right? So I'm going to get the maximum value. And you can see that here's my list. I'm going to print list first and then print the maximum of the list, right? So I'm going to Control Enter. You can see that I throw 3 times and I get 4, 3, and 2, right? Out of this 3 number, the maximum, which I used here, is 4, right? Okay, so it worked, right? This is, we do the experiment one time. We do the experiment one time, right? What if we are doing the experiment many, many times? Let's say we're going to do the experiment for j in range, let's say 1,000 times or 10,000 times. Let's do 10,000 times, okay? So I'm going to do the experiment 10,000 times. For each experiment, I'm going to throw the die 3 times and find the maximum value, right? And then find the maximum value. And that, so I'm going to find the maximum value. And also, I want to have a place to hold, to add all the result and basically find the mean value of it, right? So I'm going to say the expected, well, actually, I'm going to use the sum. I'm going to define a variable which is called sum of, all maximum equals to 0 at the beginning. What I'm trying to do is that I'm going to use sum of all maximum at equal to maximum of this. What we had before to calculate the sum is this, right? Sum plus maximum of list, something like this, right? What you had before is like this. This line basically equals to this, right? They are exactly the same. So great. So we can use a shorter one. So I remove this. This is going to be the sum, right? Then we can run this 10,000 times and basically get the sum of all the values. And then we can use that to print sum of all the maximums divided by the 10,000 times, right? That gives us the expected mean value. If you can throw a die 3 times, what will be the maximum, right? It gets close to 4.9. It's get close to 4.9, which tells us that Okay, if you can throw 4 times, 3.5 is not your expected value anymore, right? It's bigger than that. It's bigger than that. In this case, the maximum will tell you that if you can throw 3 times, the maximum actually going to get you, the average will be about 4.9. So you want at least a 4. It's not as high as 5 yet, but you at least want a 4 to be satisfied, right? Meaning that throw 3 times, if you get a 4, you will stop, right? Because it's not going to get a 5, but 3 will not satisfy you anymore. All right. I hope this makes sense. Again, let me know if you have any questions regarding all the codes, and we'll talk about probably conditional probability next time. Okay. See you.